Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. Before we dive into the topic today, I have a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. But I want to provide an additional mechanism for any questions we miss. If you'll visit aka.ms/MCAS community, you'll be able to ask questions on our Microsoft Cloud App Security Forum. If you're listening to this after the fact as a recording, that's also a great place to ask a question. By the way, any of the links that I reference here are in the IM window on the side there. We always love to hear your feedback on these webinars, so please tell us whether they are valuable to you and how we can improve at aka.ms/MCAS webinar feedback. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/MCAS recordings. While you are there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to the engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a fascinating topic for you today. We'll be talking about Microsoft Cloud App Security. Specifically, we'll be talking about extending real-time monitoring and controls to any app. I'd like to introduce you to our presenter, Alex Ezebov. Alex is a member of the MCAS product team, so he has deep expertise in this topic. Without further ado, I will turn it over to him. Alex? Alex, you're on mute still. Alex?
Yep. Can you hear me now?
I can hear you now. Thank you.
Okay. All right. Let's try that again. So thanks for the introduction, Ryan. Like you said, my name is Alex. I'm one of the product managers on CloudUp Security, specifically talking to you about real-time controls today. So there's a handful of slides that I'd like to walk you through, really not that many, and then I'd rather actually show you the feature as a real-time demo. So we'll go into the CloudUp Security portal, and then we'll have the end user experience showcased for you as well. So I think you all know this, but just to orient everybody to what we're talking about here today, when we talk about CloudUp Security or any CASB for that matter, there's sort of three basic types of things we're talking about CASB doing. One is how CASBs work to help you triage and block and allow various applications and specifically detect unsanctioned applications. One is for the sanctioned applications in your environment. What does a CASB enable you to do by giving you deep monitoring and controls there? And then the third one is across all your cloud landscape, so unsanctioned and sanctioned applications, there's a bunch of different cloud threats, and CASBs need to be able to capture those cloud threats regardless of how they come in, and help you to be able to deal with those and understand what kind of risks are present in your environment. I think you all know this, but at this point, users can access these applications from just about anywhere. It could be corporate, it could be public Wi-Fi, it could be internal or external users, it could be managed or unmanaged devices, among a myriad of other conditions. And all of these conditions kind of point to the fact that the threat landscape is complex. You can have various threats at various times in various applications, so you need to be able to deal with them appropriately. So that sort of brings us to the various architectures of CASBs and specifically the controls that they enable. So specifically today, we're going to be talking about the last one on this list, conditional access app control, but I'm going to walk you through just a brief intro to the pros and cons of each, so we can kind of orient to how we got to any app with conditional access app control. So like we saw on the last slide, discovery is all about triaging your unsanctioned applications, understanding your environment, understanding which apps are users using that they shouldn't be using versus which ones that are they using that we do want them to be using, and then taking appropriate action. Discovery is super good at seeing thousands of different applications and knowing a whole lot about their security, their compliance, their legal, their general characteristics, but it doesn't give you deep visibility into what's going on inside of these applications. So that's where something like app connectors or API-based controls come in. So API-based controls are for a much narrower set of applications, but a much deeper visibility into each of those applications. So think about hundreds of granular actions that are specific to every one of the applications we support, and that enable you to take governance actions and get visibility in near real time. So for example, AWS, if you've got S3 buckets that have confidential information stored on them, you can detect that confidential information. And if you see that an S3 bucket is publicly shared, you can go ahead and revoke access to it, or basically make it privately shared again to protect that info. So this is super good at deep visibility and control, but there is an inherent delay because it's API based. That delay could be 30 seconds, it could be a couple minutes, but the point is that from the moment an action takes place to when we're able to detect that action and then remediate that action, some time has elapsed. And so that brings us to the last control on this screen, the conditional access app control. So the scenario there is, hey, for a bunch of applications, there are conditions under which we want to be able to prevent data exfiltration, like in that AWS S3 bucket example, or prevent data infiltration, or target specific custom activities in real time. We can't afford that 30-second or couple minute delay. And that's where something like this conditional access app control, which is reverse proxy based, would come in, so that you can say, hey, I actually want to block download of sensitive resources to my mobile device as it happens. I don't want to wait a couple minutes and then be alerted on it, because once the data is downloaded to that device, the damage is done. Maybe that device isn't PIN protected, and I'm afraid that the user will lose it with sensitive data stored on it that anybody could now have access to. So What does that bring us to? So for those session controls, for discovery and for app connectors, we talked about discovery covers a wide set of applications. App connectors, by virtue of being API based, only supports the applications that have a robust API that Cloud App Security has integrated with. Session controls, the sky's the limit in terms of web applications, as long as they're enabled and controlled with an identity provider. And we have a bunch of integrations with Azure AD that I can get into if there's interest around that. But the important thing here is that when we started session controls, we enabled this reverse proxy architecture behind a few sort of featured applications. We started with Box, for example, and the next application that we added was Salesforce. And the reason we were adding one application at a time is because we were testing the application behind this reverse proxy, making sure that our injection of various JavaScripts and controls on top of the web app didn't adversely affect the application. So we would run a series of system tests, automate a bunch of tests, etc., to ensure that the experience was seamless. But again, nothing was preventing us from extending this technology to any application. So the story that we wanted to tell about these controls was, hey, you can get a bunch of different controls in real time and visibility in real time in any application based on any condition. And so we keep evolving the story to truly head to that any control, any app, any condition. And this, what we're talking about today, is how we've sort of extended it to any application truly instead of a list of featured applications. So like I said, any browser application can technically be supported. We test a bunch of modern browsers like Edge, Chrome, Firefox, Safari, IE 11 to make sure the experience is optimal. And these are the problems that we ran into before we introduced this flow. So we had a list of featured applications. Like I mentioned, we started with Box and then Salesforce, worked our way out to about 10, then 20, and now we're at about 30. But requests kept coming in for new applications. And we had this backlog of applications, and we wanted customers to not have to depend on us in order to start testing these applications and using them in their production environments. And sort of the second piece of that puzzle is custom applications. There's a bunch of goodness in this feature that can be extended to a custom application, but of course, we would never be able to test a custom application on behalf of a user because we can't get a license for a custom application that you've developed that's unique to you. And so we did a couple integrations there with specific customers where they came to us and said, hey, we'll give you an account in our custom application for you to be able to onboard it. But it wasn't a sustainable method. We wanted to truly turn this over to the customer and let them onboard their own custom applications and work and partner with our team in order to be able to do so. And that's why we introduced the solution that I'm going to talk to you about and show you today, which is basically self-service onboarding of any web app. And I did put some caveats there in parentheses that specifically what we're supporting here are Azure AD connected SAML and OIDC applications, which is pretty much the whole library minus a few applications of apps that can be supported in Azure AD. So I kind of already walked you through the timeline here. This is a quick timeline, and then we'll jump to the demo of how we sort of got here. So what we started with, like I said, in popular applications, Box, Salesforce, Exchange Online, etc., was, hey, we'll give you out-of-the-box control of download, print, copy, cut, upload, and paste in popular applications. And then we started expanding to custom activities. So we had customers come to us and say, hey, those basic controls are great, but on top of that, we also have controls that are unique to applications. Like in Slack and in Teams, we want to be able to block sending of sensitive messages. So that's what you can see on the screen here is two users interacting, and the second one of them sends something with password information. That message is blocked in real time because it's got sensitive information in it. Then we move to on-prem applications. So this is a super interesting integration that our Microsoft Story allows us to complete, which is the Azure AD App Proxy is a feature that lets you host your on-prem applications and make them internet-facing. So we extended these same controls to applications that are hosted by the Azure AD App Proxy. So you can apply parallel controls to what you've got in the cloud to your on-prem environments and apply those same sort of data exfiltration and infiltration controls. And that brings us to where we got to today. This is the last slide I'll show, and then I'll pivot to the demo, which is, hey, now we want to turn this over and give you those basic controls of download, print, cut, copy, paste, upload, all inside of any application that you would like to onboard yourself. So with that, I will show you how this feature works, and then I'm happy to take any questions after that. So I'm going to stop sharing my screen here for a second, reshare it so you are with me looking at the Cloud App Security dashboard. All right, so you should now be looking at the Cloud App Security dashboard. And this is the basic page you get to when you go inside of the CASB solution. It's got a bunch of general characteristics about your environment, how many open alerts there are, which applications are being protected, what are the top sort of activity matches or users that are suspicious or culprit. But specifically here, what we're going to do is pivot to this page for conditional access app control, which is of course the feature we're talking about today. So here you can see a bunch of applications that have been forwarded to this tenant from Azure AD, from conditional access. And you can see some of these applications have session control listed here as an available control. That means, hey, we're able to take this application and block download, upload, cut, copy, paste, all in this application out of the box today. So you can see, for example, AWS is one of these applications, Atlassian, so Jira, Confluence, etc. So these are on that list of featured applications that we've added. Now you can also see some other applications here where the option is to request session control. So there's no session control available today, but you can ping our team. I can say, hey, I want to have session control in this Find Time application. I can add some comments. Say it's okay to contact me about this, click submit, and an email will go to me and our whole engineering team so that we can then onboard this app for you. This has always been there, and this is not what we're talking about. So what we're talking about here is, let's take, for example, Microsoft Forms. So I will go to Forms, and you'll see that Forms is connected, but only with conditional access. It doesn't have the session control capabilities. So one option would be, again, to send this to my team and say, hey, I want to have this application onboarded. But now the second option is for you as an end user to actually go ahead and onboard this application. So how does that work? So I go into the settings page. I scroll down to the bottom where I've got conditional access app control listed, and I see this app onboarding maintenance setting all the way at the bottom. So here I see a select group of users in my organization that I've said, hey, I want these users to be onboarding users. I want them to go in and ensure the stability of the application, make sure it works okay, and get a different experience than the rest of my users. So if I route, for example, all of my traffic through the reverse proxy for Forms, is going to bypass that traffic for all of the users until the app is onboarded, except for these 5 users. So these 5 users will get the onboarding experience. The rest of the users in my organization will be bypassed until we actually onboard the application. So now I'll walk you through what the onboarding actually looks like as this user, Alex at MCAS Test 9. So I'm going to go to the Forms application. And now because I'm Alex, I'm going to get a different experience when I log in. So that's what you see here. I get this, hey, this app needs to be onboarded. So it tells me confirm you're using a test policy, configure the application in Cloud App Security, which we've already done. That's what we were looking at earlier. Then this is a very important step. We need to download and configure a self-signed root certificate. So our reverse proxy works by rewriting the URL of the application. So instead of forms.com, you'll hit another endpoint like forms.com.us CASMS or admin CASMS in this case. And you need to have a self-signed root certificate on your machine to ensure that we can actually render all of the pages of the application during the onboarding process. Now, while you're onboarding, we see these endpoints and we create a permanent certificate that then we can use. So it's not like your users will all have to go in and install this self-signed root certificate. This is just for the onboarding administrators so they can go through the application and verify that all the pages work correctly. So I'll click on current CA here. And you can see a root certificate appeared here. I'm not sure if my screen is smart enough to show you this warning message because I'm only sharing the browser, but I'll pretend like it is. So right now I'm adding this certificate. So all I have to do is click install certificate. I can choose current user or local machine. I can choose the specific store where I want to place the actual certificate. So I put that in my trusted certificate authority store. I click finish and I click install. So the import was successful. And now I can actually continue to the application and you'll see what this experience looks like. So now I'm inside of the application. You can see how quickly that actually loaded up. And you can also see that the endpoint I'm on is forms.office.com/admin US2 CAS-MS. This is specifically this onboarding endpoint where now you can go through and verify that everything works correctly. So I'm in the forms application now. I can click around. I can make sure that everything is loading as expected. I can pop up a new form, say, hey, I want to create a new survey, test to make sure this survey works as expected, add a couple questions. And I can see that everything is working exactly as I would expect it to. Now, if there are any issues during the onboarding process, there's always this panel at the bottom that you see that says, hey, Cloud App Security Admin View, and you've got this option to report an issue. So let's say something wasn't working correctly in your custom application or application you were onboarding. I can go in and I can say what wasn't working correctly. Maybe I have a broken functionality where maybe my name icon doesn't load or something like that. I can click broken functionality. I can say name didn't work, and then I click submit. And I also have this very important, it's okay to contact me about this. This goes directly to create an issue for our team to track, as well as a Teams message. So everybody on my team, as soon as you submit functionality like this, sees this issue and starts triaging it and making sure that it gets prioritized correctly. I'm not going to click submit here because if I do, my team will literally start working on this issue. So I'm going to click close. But you can see that Forms works as expected. So let's say I've onboarded this application and I'm ready to turn it over to my environment. I don't want just those 5 users to get this onboarding experience. Now I want everyone in my organization to go through this proxy so that I can do things like block download of sensitive surveys when I'm coming from an unmanaged device. So I can go back to Cloud App Security and I can go back to the Forms application in Conditional Access App Control. And here where we previously had request session control, if I go into edit application, then I can choose this use with conditional access app control checkbox. It's one checkbox that says, hey, I'm ready to turn this app over to be used in my production environment by all users, not just those onboarding users. So now you can see that session controls are available for this application. So now I need to go ahead and make sure that I've got the right policies in place. I believe that I do actually have a block download policy in place already. So what I'm going to do now is reshare a different browser so I can show you what the end user experience will be like after the app is onboarded like so. Okay, so in a few seconds, you should all be staring at a new browser. So now if I go to forms.office.com, of course, this is all dependent on that setting that we just switched, syncing to all the various data nodes or all of our proxy nodes, which can take up to a minute sometimes. So we're just going to hope for the best here and assume that it's already synced the change and the app has gone through as onboarded. So I'll click sign in here. I'll log in as that same user again who was an onboarding administrator, but now that the app is turned over for use in the production environment, then they should just get the end user experience. Let's make sure I remember my password. All right, so now I clicked sign in. And you can see that the endpoint is now different. So instead of admin CAS MS, when the user was an onboarding administrator, now we're on forms.com.us CAS MS. So this is now the endpoint that all your end users will see. You can see that survey we created earlier is preserved. And I've got this other customer questionnaire here that I built specifically for this demo that has some questions about, hey, how long has your organization been a customer of our company? How many licenses do you own? Some confidential information that you might not want customer data to end up on an unmanaged device. So I've got this survey built. I've got some responses here. And now as an end user, let's say I decide that I want to open those responses or download those responses and look at them in Excel, but I'm coming from an unmanaged device. So because I came from an unmanaged device, and now this custom application in the eyes of Cloud App Security has been onboarded, we can now take controls inside of this application. So we can do things like block download of this questionnaire because you're coming from an unmanaged device and there's sensitive data contained in it. You can also see that there was a tombstone file downloaded here. Because we initiated the download process, we need to have some kind of file downloaded. So we actually swap out the file. So instead of the original file being downloaded, you get this TXT document that says, hey, this was blocked because it contains data that's not allowed to be downloaded. You can also apply upload controls, copy, paste, print controls, all to any application that you want. And so that sort of enables you to extend this this powerful control and visibility and monitoring into any application in your environment, whether it's a SaaS application we have not gotten around to onboarding yet and it's on our list, or whether it's a custom application. So I'm going to reshare the PowerPoint just to leave you with one slide here, and we can use that to have the remainder of the discussion and open it up to questions.
Great. Thank you for that, Alex. So we got one question here. It says, so if I understand well, if an app like Forms is not onboarded, users will still be able to leak data even if a DLP policy is enabled?
So I want to make sure I understand that question correctly. So the idea is that without any of the controls in Cloud App Security, unless an app has built-in native controls to control things like exfiltration of highly sensitive data or data that has specific DLP matches, then yeah, you would always be able to leak them out. So the idea here is that by onboarding to this feature, then you can make sure that you have DLP policies in place so you can do things like block downloads of sensitive content.
Okay, great. You mentioned briefly what types of apps were supported as far as the SAML and AD stuff. Can you talk a little bit more about what isn't supported so people know kind of the boundaries of that?
Yeah, sure. So in general, our reverse proxy works with any identity provider. Specifically, it's GA'd with Azure AD as the identity provider, but there is a private preview of any identity provider on the planet. So as long as an app is configured with single sign-on with an identity provider, that's the first sort of prerequisite. And the second one is that we've specifically onboarded ourselves to the OpenID Connect and SAML protocols when supporting Azure AD, and the SAML protocol when supporting non-Azure AD identity providers. What that leaves a gap in is, for example, there's still, I believe, 3 applications in Azure AD that use the WS-Fed protocol. So those applications would not be supported with this feature. There's also a handful of applications that don't support the regular authentication flow. So Azure AD built in a feature called password-based SSO that involves installing basically a browser extension that gives you functionality similar to a typical auth flow like SAML or OIDC Connect. We have not integrated with password SSO applications yet either. So there are some gaps there in terms of the protocols we support, but by and large, SAML and OpenID Connect are the 2 biggest protocols in Azure AD and in any identity provider, and those are very much supported.
Great, thank you. Do you plan on aligning controls, i.e. CA app control for desktop, mobile apps, and web in the near future?
That's a great question. So I wish I could. The limitation with desktop applications and mobile applications is that app developers can pretty much do whatever they want with them. Some desktop and mobile apps are basically browsers with a slightly cleaned up sort of picture, and those we could support today if we just turned these controls on for them. The reason we've chosen to avoid the mobile and desktop app game is because they can break us in a second. So any desktop or mobile app provider could do something like SSL pinning. And as soon as that happens, there's nothing we can do to break and inspect the traffic. We would actually break on the authentication flow. So there's a myriad of reasons why those applications don't play nice with reverse proxies. So they're not something that we're planning to support or add parity to with these controls. Now, there are a couple sort of disclaimers I should give with that. One is that if we had no controls for your mobile or desktop apps, the story would be incomplete because then users could exfiltrate data or infiltrate data via those applications. So one of our most popular deployments is create a policy that enables things like block download that you just saw in the web application, and create a respective policy for the mobile or desktop app that says, hey, I want to block access altogether. And then you'll get a nice block access message that will say, hey, you can't get there from here, or whatever you customize the message to say. Please go to www.forms.office.com or whatever the browser-based instance of that application is. And then you can apply those session controls there. So that's caveat one. Caveat two is that we're doing a bunch of powerful integrations with Windows Defender or Microsoft Defender Advanced Threat Protection to be able to protect applications on the endpoint. So there's a lot more that's coming there. I know that you've probably all seen the sort of the discovery-based integration around being able to detect those applications on the endpoint. Now we're adding the ability to actually block those applications on the endpoint, and there's more work that's ongoing there that you'll hear much more from us about in the coming future.
Okay, fantastic. All right, this next one is a little bit longer here, so bear with me and make sure I relay it correctly. Mm-hmm. Is there a way for MCAS to target a file policy to guest users and teams? At the moment, it appears as though external does not include guest users. They are treated as internal users, and collaborators isn't able to go down far enough to see the user. The event in Teams only shows collaborators as Teams internal user and isn't able to check user type attribute for guest.
So off the top of my head, it's a great question. I don't know the answer off the top of my head. I would be more than happy to take that one offline with whoever wrote it. I'm staring at the screen I'm sharing, so I can't see who's writing these messages. But if I'm happy to leave my email, or Ryan, if you want to drop my email in that chat, sure. I would be more than happy to follow up and make sure we get that question answered.
Okay, great. We got the next one here. Is it possible to prevent users from uploading files to OneDrive with a specific AIP label with this function?
Yeah, absolutely. The upload functionality we built in is actually specifically with that use case in mind. Obviously, there are hundreds of others that can evolve, but the reason we said, hey, upload would be great to build is a lot of customers came to us and said, hey, we want to make sure that our users are creating the right labels on our files before they're uploaded to the cloud. And so what we do is you can actually create a policy that says, actually, you know what, I'm just going to show this to you. If my screen cooperates, of course. Okay, well, it looks like my screen's not cooperating, so I'm stuck in presenter mode. But I would be more than happy to walk you through that, or just kind of like verbally explain how it would work. You would create a session policy. You would say, hey, I want to block upload. And then under the file filters, you can actually choose labels. And then within the labels, you can choose any AIP label that you've created in the actual AIP or SCC dashboard, depending on if you've migrated over to unified labeling or not. And all of those labels will actually sync to Cloud App Security, so you can apply upload controls on any type of label that's being used in your organization.
Perfect, thank you. Next one here. If you're doing these controls in browser apps, what is your recommendation for controlling the apps, mobile, desktop, etc.? block them since MCAS can't control it?
Yeah, that's exactly it. This question was probably asked in parallel with the other one, but absolutely. So because we think of this feature as sort of this feature is intended for risky situations. Some of our customers proxy all their traffic. Majority of our customers proxy risky traffic, whether that's guest users, unmanaged devices, etc. And so in those cases, what they can do is they can create these controls for browser applications and create parallel controls for mobile or desktop that say, hey, block access and route users to use the web application instead.
Okay, great, thanks. Is there a way to allow users to log on to my company's Salesforce application or any other app subscription, but not allow them to log on to other Salesforce subscriptions?
So very, very, very good question. Not with this functionality. The reason that's the case is because what we're talking about here is specifically apps integrated with single sign-on. So we can let you control which apps with single sign-on they can log into in your environment. But if you've got multiple instances of Salesforce that have different authentication flows that do or do not go through your identity provider, then this isn't the right feature to solve that issue. Now, to solve that issue, there's a couple Microsoft solutions, and there's also the discovery scenario that we talked about here. The interesting thing is some applications have URL filtering for different instances, and some don't. For example, Dropbox is Dropbox regardless of whether you're using your personal instance or whether you're using your corporate instance. And in the case of Dropbox, then Cloud App Security and the discovery feature won't know which instance to target. So you can either allow or block access to Dropbox. For some other applications, you can actually get more granular and you can build out rules for specific URLs and say, hey, I want to 1.x.com I want to block, but 2.x.com I want to allow. So the answer is it's app dependent. The core functionality is there, but depending on how the application has actually implemented multiple instances, you can get a mix of results.
Excellent, thank you. Next question here, do you have controls to prevent exfiltration of mass downloads, i.e. cap the max number of file, folder, or item downloads per SP or site or group?
So not today. Today we have mass download as an alert that pops up inside of Cloud App Security, and that's agnostic of the mode that you've integrated the app with. So if we see a mass download from our API, or if we see a mass download from our reverse proxy, we'll still show you, hey, mass download occurred in this application. Now that again is retroactive. It's the alert pops up after the download has occurred. We have not gone in and implemented a real-time control on stopping mass download, although there's nothing technically stopping us from doing that other than clear-cut sort of requirements and a technical spec on exactly what customers would like to see there. So for whoever wrote that message, because again, I can't see it, I would be more than happy to follow up with you and hear exactly the use case. Like, do you want to make it configurable by time, number of DAV files downloaded, type of file downloaded, the data contained within there, etc. And then we can talk about whether that's something that we can build for you.
Do we have any plans to deepen the integration with SPO/ODFB without having to use a proxy URL?
So that's a great question too. This proxy is one way to get session controls. Some applications have gone in and built sort of custom session controls that are available in that application natively. SharePoint and OneDrive are actually an example of that. So they've got these native, I forgot the exact name, but basically these native session controls built in that allow you to block download, print, and sync from some specific conditions. And our recommendation there, of course, is if you want to avoid using a proxy, then by all means, if your use case is supported with those features, then use those features for SharePoint and OneDrive and the apps that support it. Now, the reason we see traffic to OneDrive, to SharePoint, is because there's other use cases that are unlocked with this functionality, like scanning for AIP labels, like protecting the files on download, upload controls, copy paste, etc. So the answer is there are ways to avoid it depending on your specific use case. We have not talked with that team explicitly about a way to sort of unify the controls, but anything's on the table. So if there's something that's missing from those native controls that you would like to see, us implement or them implement in a way that bypasses this proxy, again, would be more than happy to talk to you about it.
Okay, great. Next one here. What exactly is inspected? For example, if I session control Slack or Workplace by Facebook, is it only files and API labeling managed, or can I manage chat conversations too?
Yeah, it's a great question. So by virtue of being a man in the middle, we can inspect any request that gets sent to and from the server. Now we don't know what every single request means. We specifically, like I said, we look for upload, download, copy, cut, print. But we've also figured out in some applications, custom actions. Like the one I was showing earlier was inspect sending of messages in Teams. And I actually mentioned, I think in the text, that Slack was supported as well. So I'll bounce, my screen is still frozen. So yes, the answer is in some applications, we've built custom controls and custom activities on top of the basic, the rudimentary exfiltration and infiltration scenarios. Teams and Slack are in Salesforce, and Workplace by Facebook are a great example of those. We've done some in Box as well. So it really depends on what customers request. When a customer comes in and says, hey, I need something more than download, upload, etc., then we work with them to onboard the activities that they do need.
All right. What's the recommendation for DLP controls? You can search and apply DLP controls for data at rest in SPO and OD4B, but there's no way to configure this for data in transit, email/XO. For XO, you need to use security/compliance portal to configure these policies.
So you are actually able to configure DLP policies with this setting. Now the question is just what is your use case ultimately? So the conditions where we see customers apply DLP policies with the reverse proxy is usually around data exfiltration to unmanaged devices. So similar to the scenario I showed here. Basically, the use case is, hey, I know what my sensitive data types are, and whenever I see a sensitive data type like that coming to an unmanaged device or for an external user, then I want to block download of anything that contains that data. And that's all feasible to do with the feature you saw today.
Okay, great. Got a question here. Is there an ETA for the Defender ATP integration with MCAS where unsanctioned applications are blocked?
Yeah, so I actually don't know if I don't remember off the top of my head what the status of that is, but the announcement's been made. I believe that it's already in preview. I'm happy to relay that message back to our team and get back to you with an exact ETA, but I believe that functionality is already available to customers in preview.
Okay, great. Someone says here, when configuring user action policy to disable file downloads, I can't see file download not available in actions list. Is this my tenant or is something missing in the configuration?
Can you read that one more time?
Sure. When configuring user action policy to disable file downloads, I can't see the file download. It's not available in the actions list. Is this my tenant's problem or some configuration missing?
I'd be happy to look into that. I assume what the user's saying is that it doesn't appear inside of the activity log in Cloud App Security, like the download event after the downloads occurred. I'd be more than happy to take a look at that.
Great. Will MCAS be integrated with other than Azure App Proxy, such as Zscaler, ZPA, F5?
So nothing on the roadmap today. Again, open to having those conversations. Zscaler is a great partner for us. We've integrated with them in discovery, and there's always room for collaboration in these areas. So I would love to discuss your exact use case. If you're talking about, hey, I want to get to on-prem applications, we're actually doing a lot of thinking about how we can get to those applications directly with Cloud App Security as well. So that one especially, I'd be super interested to follow up with you and hear about exact use cases, whether it's HTTPS or whether you're talking about RDP, SSH, SMB, etc. And we can talk about our thinking around those topics.
Great. Next one here is, I believe EVM is coming in and can be used with DLP and MCAS policies. Can you tell us any information on how that will work and when it's likely to be available for preview?
So I don't know any information on top of what you just said. I would be happy to connect you with Danny on our team, who's the definitive expert on that one.
Okay. Regarding the Defender ATP integration for enforcing the unsanctioned apps block list, would we, let's see, we would want to block consumer OneDrive but allow upload to one or more ODFB tenants. Is this coming?
Let's get Danny on the line for all the Microsoft Defender ATP integration questions. So if Ryan, you're welcome to drop my email or Danny's email directly, whatever you prefer inside those questions, and I'd be happy to follow up or have Danny follow up with them.
Great. I just dropped Alex's email in the chat there for anyone who needs that follow-up info. Okay. Looking here for any additional questions. I think any of the other ones I'm seeing here are kind of, we had several come in parallel that I think we already addressed the substance of. I'll give people one last chance here as I post a couple of reminder links here for those who may have missed them at the beginning. If you are looking for the recordings, you can find those at aka.ms/MCAS recordings. If you have a question that we didn't get to here, if we somehow missed it, or you're listening to this after the fact as a recording, you can ask any questions you have at aka.ms/MCAS community. We always love to hear your feedback about these webinars. You can give that at aka.ms/MCAS webinar feedback. And we always like to have more members of our community. We hope you've joined already, but if you haven't, you can join that at aka.ms/security community. And what the difference between that and the MCAS community is the MCAS one is obviously specific to Microsoft Cloud App Security. The security community one is broader. It's all of our security products. So if you are interested, stop by there. Let's see. Regarding oversharing of data, what controls do we have that would prevent these type of incidents?
So there's a lot of the API connected applications that give you visibility into sharing activity. So OneDrive for Business, SharePoint, Box, AWS, Salesforce, etc. And depending on the application, there's a bunch of different controls you can take. You can revoke access for specific users. You can be alerted to when it's public and make the access private. You can encrypt the data so that even if it's shared publicly, users that aren't meant to see it won't be able to see it. So it really depends on the exact implementation details that you would like to have in your environment. But the short answer is we can get visibility into many, many sanctioned applications in terms of sharing activity, and then figure out the right remediation action to take.
Okay, great. We've got one last one here. This is worded a little bit as feedback, but I think they're asking you to speak to this area. It says, the hard thing with mobile apps such as Salesforce is if this app has more features and works better than the web-based version, there is no option to make sure a managed device is connecting to MCAS controls via reverse proxy are applied. Mm-hmm. So it leaves a control gap where the company needs to force to block the mobile app.
Yep, totally sort of empathize with that comment. The tricky thing is that we want to make sure that we simultaneously balance security and productivity here. So we totally recognize that in some situations you're diminishing productivity in order to get security controls, and this is one of them. So like you exactly pointed out correctly, our reverse proxy architecture cannot be put in front of a mobile application, or at least not reliably. So in those cases, you wouldn't be able to get those features you'd normally be able to get with a mobile app at that's the price you pay for getting the security controls on top of the regular web-based Salesforce application.
Great, thanks. Has the integration with Zscaler or Discovery been updated so that it's easier to initiate?
So I would be happy to, I wasn't aware that it was difficult for anyone to initiate it. So would be happy to follow up there and figure out the exact trouble that you're having. But it is that integration gets rid of the need for a log collector, gets rid of the need to upload block scripts to your firewall proxy, etc. It makes everything, you set it up, and then it's two-way API-based communication. So I would have thought I'm surprised to hear that there was difficulty setting it up. I'd be happy to double click on that.
All right, and for any of these, as Alex mentioned, if you want to dive into a really specific scenario to you, if you have to share any private information or anything, you can do that with his email address. If you just have a more broadly applicable question, you can ask it on our community anytime, and either Alex or someone on the team will be watching for those. Take one last one here. I don't know if we can do this, but someone's mentioning, do we have anything interesting, kind of a preview about what we'll be sharing at Ignite?
There's a whole lot. I don't know what I'm allowed to talk to and not talk to on this call, so I'm going to leave it at there's a lot of exciting announcements coming, but I don't think I can dive into details yet.
All right, sounds good. Okay, I want to thank all of those who helped answer questions through the IM window on the call. Of course, I want to thank Alex for a fantastic presentation. Most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Thank you.
Thank you, everyone.